Hello everyone. So my name is Kai. I'm a co-founder and CEO of 3D Architech. So I'm a visiting scientist at MIT, and also our startup 3D Architech is selected for Start Nano Accelerator Program by MIT Nano. So here's our vision. So we revolutionize the metal manufacturing platform to realize the imagination with a complete freedom of materials, microarchitectures, and production volumes. And behind this vision, we see the two fundamental problems in the metal manufacturing space. The first problem is a manufacturer resolution, how fine you can make the metal devices. So performance and efficiency of metal devices are locked by currently the limited micron scale control and also material selection that can achieve such a micron scale control. One of the good examples is the heat exchanger heatsink. Those are made by the copper fin structure, which is 100 micrometers thick fins. If you could make it smaller, you could improve the cooling performance. However, we reach currently how fine you can make by current manufacturing process. The other problem we see is the trade-off between part cost and production volume. We always need a mass production because of the high upfront capex. Again, the good example, traditional example is the metal injection molding. The mold costs $100,000, so you have to pay the upfront fee $100,000 to make even one design of the product. Metal 3D printers have emerged. However, we still need a mass production by this technology. The reason is that metal 3D printer is very expensive, usually costs $1 million. The most affordable ones still cost $100,000. So to tackle these challenges, we invented a new technology of making metals, which is a gel-based metal 3D print technology. So instead of using any metal material such as metal powder, metal wire, we use a gel. So we have the proprietary gel materials, which can be 3D printed by commercially available UV light-based 3D printer, which is typically used for making a resin or plastic. But by using this 3D printer, we make a 3D structural gel. We have a chemistry that can convert from gel to metal. So basically, what we do here is that we use a commercially available UV light-based 3D printer, which is used for making the resin and plastic, but we use this type of 3D printer to make metals. So here's the advantage on the right. So you can offer 10 micrometer feature size, which is 10 times smaller than any metal 3D printer can offer. And also you can offer versatile material sections, including pure copper or tungsten. We can also do multi-material 3D printing. And this type of 3D print is very affordable. Usually costs $1,000 per printer. So it's 100 times lower equipment cost. And this allows us to do low part cost, even from one piece of production. And by using, here's what we can make, just a good example. So here's a silver structure, which has a 40 micrometer feature size. It's the half size of a human hair thickness. And by this high resolution of fine features, we can make more than 3 centimeter structure. It's a good size for the heat exchanger heatsink. It's made by copper. We can also make different type of alloys. It's basically different combination of metals. And so far, we have gained more than POC study requests from the more than 6 companies in the different markets, the heatsink, hydrogen production, electrical connectors, and electrical motors. And today, we are working on mostly the heatsink market with 6 different customers. And let me show you today the one use case, the data center cooling. So in the data center, the GPU, TDP, the thermal design power has rapidly increased. And if you look into the energy consumption in the data center, the 40% of the data center consumption comes from the cooling. So we need a new cooling solution which provides a super efficient cooling here. So instead of using the traditional manufactured structure, like CNC machining structure, we offer the 10 micrometer feature size with a topological optimized structure by using our technology, which offers 4 times energy efficient, and also the price point also is quite competitive by this technology. So here's our ask for the partnership. So we do right now proof of concept study with various companies for future partnership. And the specific application we're working on is right now the heatsink, especially liquid cooling heatsink, wicks for the vapor chamber and immersion cooling. We're also working with the companies who are interested in the water electrolyzer and fuel cell gas diffusion layer. If you're also interested in this manufacturing process, we're happy to work with 3D printing service bureau, which should be equipped with 3D printer they need, and also we need also some equipment for post-processing. With that, thank you so much. We are 3D Architect. We're happy to answer any questions.
Thank you, Kai, so much. Could you talk a little more about the gel to metal conversion?
Right. So this is what we actually do. In the practice, what we do here is that we don't have any metals, as I like to emphasize here, in a gel, in the starting material. It's just gel as a material. But instead, after printing the gel, we have some conversion process, basically infused into metal precursor solution to infuse metal precursor into the gel, and you have a burning process basically to burn out the gel and also convert from convert from metal precursor to metals and to make the metal structure here.
Okay, and how do you generally work with corporates? Do they provide a design? Do you provide that?
Yeah, that's a good question. So it's company by company. Some companies are interested in our technology for the high resolution 3D printing, and they have a specific application, but however, they don't know how to design or take advantage of such fine features. So you have the simulation team in our company. So depending on the company, we offer a design, or if the company has some design in mind, we offer to also just manufacturing as well.